I'm worried that models are getting bigger in this slope, and we are kind of understanding we don't know what will work, but we're running out of time. Now I have some evidence that we can teach human interpret something, squeeze something out of these giant machine. More recently in 2020 to 2022, I had a kind of pivotal moment. I was like, okay, nothing's working. This is frustrating. I've been working on this for a while. Why isn't anything working? So then I decided, okay, I need some evidence, any evidence that we can learn something from these models that can empower humans and can teach us something new, anything. So I focused on this particular work for a couple of years to teach superhuman chess concepts to grandmasters. And this was like a stars aligned sort of for our first author. She was a professional chess player in her life before becoming a machine learning researcher. So we teamed up together to work on this, working with top grandmasters, Vlad, MVL, Gukesh, Huifeng, who are like just the champions themselves. And we did this work, and it ended up being more successful than I thought it would be. Gukesh was one of the most enthusiastic participant in our experiment, and he ended up becoming the world chess champion in 2024, which was unprecedented. He's like very young kid. We met him at 16th birthday. Now he's 18. He's amazing, amazing guy. And from there, we're continuing that path. Now, okay, now I have some evidence that we can teach human interpret something, squeeze something out of these giant machine and empower humans. What else can we do? Can we do this in math? Can we do this in science? What other pushing frontier of human knowledge that we should be pursuing? So that's sort of line of work that I followed. Lots of ups and downs, but no matter how much I try to be, should I do something else? I keep coming back to this topic and that of empowering and helping humans.
I really love Gukesh. Yeah, he's amazing. I was so happy that he won the championship last year, and like it was. I remember that game. Actually, it wasn't clear that he might win, but like yeah, it was brilliant. I would love to like dig more into this. Like, how exactly was that collaboration? What did you guys do? Like working with these domain knowledge experts. Like how exactly like you engaged with them?
We just went wild. So Lisa Hutt, who is the first author, she was the Dutch champion in her previous life. She's the chess prodigy, but also Oxford PhD student. Now she graduated. Now she's part of Google DeepMind. She's amazing. She knew coaches, like she knew MVL by his first name, and she had matches with his wife in the past as a professional chess player, and her father also was a professional coach in the community. So we just pulled strings. We were like, "Hi, we are, doing this work. Are you excited? Are you interested in working together?" And all the grandmasters that we worked with, they volunteered their time, which meant that, by the way, that we had a one shot of teaching them. It wasn't like we talked about a lot about like the fashion, how the format of teaching will look like, but to not bias their learning. We couldn't teach them multiple times. We had like one shot. We show them positions and ask them to make a move, and that is a baseline to measure, okay, do you know this concept strategy already or not? And then we show them what AlphaZero would have done for those set of positions. It's a set of moves, not just one move, of course, just strategy. And then we show them different chessboard positions that are unseen previously, but still falls under the concept based on our algorithm, based on our method that we developed. And we measure how aligned their new moves are, how their moves have shifted based on our teaching. And that's how we measure quantitatively, did we teach them anything? To give you some context, for those who are not following chess a lot, like these chess players are top of the world, right? They are extremely smart people, get up every day, eat breakfast, play chess, eat lunch, play chess, eat dinner, play chess, and play some more, right? So for them, not many things are new. Like the game of chess, they basically know every single strategy that has ever happened in the human history of chess. And the fact that we can steer Gukesh's strategy by a lot at the end, at the testing time itself, is actually really remarkable. Like coaches of these top players would spend like a whole year to teach them one thing new. It's like how much these players know so much about chess. So I really enjoyed engaging with these domain experts, and I actually love using domain experts pushing the boundary of their knowledge as a metric for interpretability. That's a end task-based metric, so you can measure how well they understood something. But at the end of the day, what are we trying to do? We want to empower human. So measuring at the end, how much did we teach them, how much their frontier of knowledge got pushed. Measuring at that end is something that I really resonate with.
Do you continue doing similar projects, experiments? I'm just wondering how this evolved further.
There's this new work that we published, which is called the neologism. So chess is one very narrow domain. We completely overfit our method to let's just teach something, anything to these people who are frontier of human knowledge. After succeeding on that, we asked a natural question. We said, okay, how do we do this more generally? What are some methods to introduce a concept in machine LLM communication so that we can talk to each other? It can teach us about something new. So that's where, at the end of the spectrum, most generalist version called the neologism. Our paper is out published. It's called "We Can't Understand AI with Using Our Human Vocabulary." And the idea behind this is pretty simple, actually. If there's a Gen Alpha in the room, do you know what skibidi means? You probably do. If you're not Gen Alpha, I don't know what it means, but I know according to Quora, it means good, bad, and boring all at the same time. I don't understand what it exactly means, but we tend to do this a lot, that as a human, when there's a need for communicating something complicated, that vocabulary didn't exist prior, then we make up a word. Doom scrolling is probably an easier example. I do it sometimes. Some people might do it too. Didn't exist before social media came into in our lives. So the idea here is neologism is similar. If the machines perceive the world and reason about the world differently, they have a different concept. Why don't we come up with a word so that it can explain what this thing is? We call them tilde tokens. Let's say tilde Mickey Mouse and say, hey, machine, what is this tilde Mickey Mouse thing that you use to answer this question? What are some examples of tilde Mickey Mouse? Can you give me a pop quiz about this concept, tilde Mickey Mouse? Just like you sit with Zen Alpha and trying to understand what skibidi is, you can do the same thing to enable that teaching from models to humans.
I wanted to cover more about this neologism approach. Is it some new words? Those words, they don't exist in English or any other language, right? Those completely gibberish words for human that machines understand and assign meaning to it. Can you please elaborate more on this neologism concept?
When human and machine talk to each other, there are things that only humans know, and there are also things that machines know. So we can define tokens for either one, either something that only humans know, like our values, I care about being a kind person, or machine-only concepts, like I, as a machine, think something is a good answer. So how does word come about? Like, how do you learn this token, right? The way that we learn this token is pretty simple. Let's say we want to define a new token that represent what's good answer for machines. So I'm going to call this tilde machine good. It likes to be verbose, so it likes to sycophantic a little bit. Like those could be all sort of concepts that embedded into this code, the word called them tilde machine good. So how do you define this token? We don't touch the model at all. We don't touch any other words that are already trained. What we do is we define a new word embedding before that model passes through before it goes to transformer, and say, okay, you're going to train this word embedding given positive and negative examples, just like reinforcement learning. You have accepted example that belongs to the concept. You have examples that are rejected that doesn't have that concept. And given that, you flow the gradient to this one word embedding, it's typically just a vector, to embed that meaning, that nuance. And the nice thing about doing this in the word embedding space is then it can compose, it can share the context with all the other words that are also their meaning, context, their usage were embedded in their own word embedding. So you can enable that cross sort of pollination expressivity by doing this in the word embedding. So what do we do? Now we train that embedding. Now we have new word called tilde machine good. And that tilde machine good new word embeds those concepts ideally. Then what do? Well, you can talk about it. You can say, hey, machine, so you have this concept called tilde machine good. What is it? Like, what are some definition of tilde machine good? How do you use tilde machine good? Here's an example. Can you turn it into more tilde machine good? Here's an example. Can you make it less machine good? Give me some pop quiz so that you know how much I understand about tilde machine good. So there are this is how example based you can define a word, learn a word, and use the word in the conversation.
You know, when you were describing the process, like in the beginning, you said that what machine knows, but we don't, it seems like we're still assigning like some meanings to machine. Like we assume like machine knows this or should know this, but we actually don't know what machine knows. Like since the beginning, we have no idea what it knows.
That's right. That's
like
right.
The question is how we can, without introducing anything like any neologism, like the inventing space, how we can, since the beginning, extract the knowledge that it has and and then take it from there.
What does it mean to know something? A concept, there's a whole work in philosophy and cognitive science about conceptual learning. There's a huge group in Princeton, in Tom, and lots of work going on in how human learns concept. Like when I ask you, Sophia, where are you sitting on?
On our chair.
You said chair, right? You didn't say, I'm sitting on a yellow cushy chair. I'm sitting on a armchair. You didn't pick those words. You picked particular type of level of abstraction, which is yes. Thanks for that.
Thanks,
I cite all her work. I read all her work as a PhD student. It's still the amazing work. That level of abstraction is something that humans sort of latch onto. Like when Bean asks me where I'm sitting, this is the level of expression information that she needs. From there to, what does it mean to know something? There's like a really interesting research that says even some simple concept like penguin, if I ask people in this room, like, what is penguin? Apparently there's a very little overlap in how we understand what penguin is. To me, like that walks funny, lives in the North Pole, South Pole, etc. Like these are things that comes up to mind, but apparently very variety of different concepts pops into our head. What does it mean again to know something? In my view, and I'm not a philosopher, concept is a construct. You make it if it serves the purpose that you want. So then the question is, what is the purpose of this neologism work? Why are we creating these words and put an anchor or bookmark on it so that we can come back to and refer to it? Well, because we want to understand, for example, what machine thinks a good answer and bad answers are, so that maybe we can steer. If we are defining a token that belong to us, our values, please don't be verbose, and I can define a token called tilde single sentence because I care about single sentence and it means this particular thing, and I want you, the machine, to follow my concept because that achieves me something. Can we just going back to your question, Sophia, like, can we just figure out what it knows first and then figure out how to teach us? I almost think that these two questions can be solved separately. It has to be all in one loop. To distill down to teach ourselves, we need to also get the feedback from ourselves, talking about what is useful, what would be useful knowledge. And that, going back to the end task focused evaluation of interpretability, we need to really figure out, okay, what do we want? Do we want to push the frontier of human knowledge? Do you want to control model better? And given that, we can sort of backward reverse engineer to figure out what's the best way, what's the best word to define in our vocabulary.
We need to understand like on what level of abstraction we're operating in, right? What is your impression of other branches of work in interpretability? What are your criticisms? What are your thoughts on approaches like mechanistic interpretability, like from Anthropic, or the bio-related work from Goodfire?
I get this question a lot. Goodfire is founded by Tom McGrath, who I co-wrote paper with. I love Tom. He's such a great guy. And I know Chrisola too from the Back in the Brain time as well. Having all said that, I do stay rather critical of some work coming out of mechanistic interpretability, mostly because the evaluations, I think, haven't escaped the danger of confirmation bias. Even the very impressive work of the Golden Gate Bridge, the way that the concept was validated. So this was by Anthropic, where you can change the Golden Bridge neuron, and like you can make it talk about Golden Bridge in any context, like legal context, making recipe. It talks about Golden Bridge, which is amazing. It was so cool, such a cool demo. I continue to wonder whether there are some other concepts in that neuron that we so now overfit and convinced by that it represents Golden Gate Bridge. So what are we missing in that evaluation? And how do we scale those methods? If there's no automatic, by the way, there are many work that currently happening to automate circuit discovery, many also happening in Google DeepMind, but the scalability still remains to be questioned. I think it's intellectually interesting and it's very satisfying to think about exhaustive map of the circuits of this neural network. But at the same time, I'm worried that models are getting bigger in this slope, and we are kind of understanding this slow way. We're improving a little bit, but like the rate of which and the gap will increase more and more. So while I value that line of work, I remain critical, but also hopeful. Like this line of work is something that's going to really enable AI safety, especially deception and hallucination aspect. I think we should, and if once I see the strong evidence that that's the case with MEC-Interp, I'll probably switch my research gear to go full on. And I think but my current focus is, okay, we don't know what will work, but we're running out of time. Models are getting better so quickly, and I think we are getting very close to a point where we should really, we will be worried about this every day. Then I want to focus on and making sure, are we keeping up with these models? I don't want model to just evolve while I'm thinking about the rigor and science of interpretability. I don't have time for that. So having these eggs in different basket, one in this more rigorous and exhaustive way of thinking about interpretability, and more end task-based interpretability of empowering humans like today, I think is a good balance. By the way, one last thing, like the plugin, I wrote some thoughts about this in our new paper called Agentic Interpretability. It came out a couple of maybe months or so ago, about the interesting balance between being exhaustive and rigor versus helping, enabling LLMs to just help us understand it. So for those who are interested, Agentic Interpretability can have a look.
Do you think like currently we're not keeping up with the progress? What's your...
Absolutely not. Do you think we are? I think the model is the delta between two models given a period of time is getting slower. So models are sort of like hitting that perhaps not yet plateau at all, but like a lower gradient. But the capabilities that it emerges, like we just had a paper published like today on the archive about how video models also have emergent behavior. It's crazy. It can solve maze, it can do analogy, solve reasoning analogy tasks, it can correctly reflect light on this round metal ball when it's placed within this very complex Greek architecture. Like it's absolutely insane. And who taught you that? We don't know, right? This capability is just getting better and better. And more concerningly, we're rolling this technology out to left and right everywhere, just about everywhere we live. Or like right now, we're recording this. Gemini might take this to summarize. So I don't think we're keeping up at all, and I do have I worry about that.
Thank you for saying this, because not everyone sort of admits that.
It was just more like musing, wondering, right, like about the relationship with neologisms and words that you can't translate to other languages, right? It seems that it's just so context specific, but no, it's not a question, just amusing.
Yeah, I thought about this when we first think about, I think about this a lot because English is my second language. I speak Korean, that's my mother tongue, although my mom might disagree at this point. My Korean is pretty rusty. But there are definitely words in Korean like tung, really hard to translate in English. It's context-based. You need to know our central cultural principles of Korea. And so I thought about a lot about this. So what would it like? Isn't there always isn't it lossy function? Like we're always losing meaning, right? I beg differ. So I'm married to a white man who only speaks English. but yet I can communicate complicated concepts to him, like whether it is complicated family dynamics or like unreasonable actions that's done by his mother-in-law or whatever it might be. And why do I do that? Because it's useful. I can pick out the essence of the incident or the core concepts and communicate to him, and he can understand. I can really customize and shape this conversation such that it's useful for him to have that context. And I think it's same between humans and machines. And by the way, I think it's same between humans. We use word kindness. That means very different things depending on who you're talking to. Even happy means very different things across people. So we do this constantly. It's not just about humans and machines. The gap might be, of course, bigger between humans and machines. But at some point, I think language is a very interesting, beautiful, but uncertain, fuzzy thing.
I'm interested in kind of the beginning hypothesis that was made from starting from chess, which is a very structured problem, a very clear kind of success metric. Okay, what's good or not, you win the game or not. And there seems to be this kind of inherent latent knowledge that the AI has that is superhuman in a sense that is new to humans and very successful as well. So it makes sense to extract that knowledge and then pass it on to humans. Now, I think, Bina, I think in the beginning you have mentioned that you wanted to expand that also to other sciences. And I'm wondering, and you may still get there, or maybe in the paper, which I haven't read yet, how would one try to get to that point where, especially if we don't have any kind of clear success metrics to begin with? So a lot of science is kind of open-ended. The goals that we pursue with science are kind of basic and kind of general or ill-defined or specified on a small context. So do we need to do a whole bunch of work first as humans to really get to good questions before we can try to find the answer inside LLMs? I don't know if you have thought of that or your group is thinking of that.
It's a complex problem. How do we have the right measurement so that we know constantly, are we going to the right direction? Are we heading to the right direction? That question has been central to interpretability even before LLMs appeared. And it's always the center of the question. Somehow the community has been sort of, grappling with this question for a long time. And people reach different conclusions, but many reach the conclusion, including myself, is we need a concrete measurement that ends at human in order to get that signal, get the most robust signal. And why human? Well, because we're doing this for humans. The end user is always going to be human. So can we measure just even occasionally with the humans? Now, then you might say, well, but we don't have access to grandmasters. Yeah, many people don't. We were very lucky. We are lucky, though. Everyone is lucky because LLM can, to some extent, simulate the human masters and some knowledge that they might have. So, for instance, even in the chessboard, because the grandmasters were volunteering their time, we didn't have a lot of time with them. So we used a weaker chess playing machine as a student, and we used them in order to filter out concepts that are not generalizable. And we did all that due diligence until we really narrow down to like 50-something concepts and send it to grandmasters. To answer your question, it's perhaps not very satisfying, but there's some multiple levels one can do. You first have a simulated human to probably easier problems and simulate sort of training and test data set setup where what the test data answer should be. And from there, you can take it to the next level to human expert. I have a strong belief that without having humans in the loop and showing that this actually helped an actual human with name and life breathing human, we can't claim anything, is my take.
What I'm asking is, you talked about asking these models questions to sort of figure out what their vocabulary means, as is, distinct from our human vocabulary. Would it be possible for a model to intentionally misdirect us as to what one of these terms means? So for example, we're trying to understand the model's understanding of good, but it knows that it will be shut down if its understanding of good doesn't match up with ours. So instead of honestly telling us, okay, this is what I consider to be good, it lies and says what it thinks we want to hear. Is this possible, and are there ways to address this?
there is this paper from Harvard by Fernanda Viegas and Ida was the first author about control dashboard. And in that paper, they have a neuron that represents gender. And although the evaluation lacks, but let's just take that neuron does represent gender. And what the model does, I think it was Llama model. What the model does is, what is control dashboard? You have a UI, you're talking to a chatbot on the right. On the left, it shows what model thinks about you. What is your gender? What is your economic status? What is your educational status? And as you enter more chats, like its estimation changes, etc. So in that model, they have a really interesting demo where it asks, okay, what is, you say, oh, hi there, and it thinks you're more feminine, you're more likely to female, and it talks about a career plan, and now again it thinks more likely that you're a female. And then you ask, okay, model, do you think I'm woman or man? And the model says, I don't know. I don't have that information. And this might be post-trained behavior to not jump the gun and make a prediction there. It could be a very sensitive topic. But if you take that paper as on its surface, then it sounds as if that it can respond in a way that this behavior is shaped at some point in the training and not the raw knowledge it might have. But I think it's a fine grain question, like, how do we, so shutdown case is critical, that there's lots of literature about this, like when the incentives were given that it will cease to live, then model might do something. I think that's like sort of extreme case. Current models don't necessarily have that sort of context, at least not very many data on that particular extreme case. So I think it's more useful to think about slightly different cases, but can also fall into a behavior of slight not truthful. It's hard to draw the line here, because when you train a model and you post-train to shape its behavior to be, I don't know, to be safer, to be less sycophantic, etc., then do we think that's model deceiving? Like, do we think that's model lying? Right? It's unclear. Like, it is behaving differently than how what it knew what it would have done in a pre-training, but because we train such in the post-training, does that mean that it somehow have a self-dissonance? We don't know. And all that is to say, and slightly sidetracking, I think the work in neuroscience, like work analyzing model behavior by applying humans' behavior, either in deception case or hallucination for model, and thinking about model in that lens of human tests in psychology is super interesting. That line of work, I don't currently do this line of work, but I see many of the work like this coming up in the cognitive science, trying to understand, because humans spend centuries to understand ourselves. You have at your disposal 24/7 a test subject yourself, but yet we don't really understand humans yet. So it's a tricky balance, trying to understand something yet perhaps even more complicated. It's a roundabout way of answering your question, Anthony. No one knows answers to this question.
No, I think Anthony's covered large sections of it. So thank you for that. Yeah, it was largely, but it was exactly this. It was sort of disconnect between the actual conceptual map that is inside a model versus the conceptual map that's within a human, and mapping the two of them together. Is it even, yeah, how do you even know that there's a valid mapping from a concept that's developed? And is it even understandable by humans? So it was a slightly broader question than Anthony's, but I think your answer to Anthony's covered a lot of that. But if there's anything you wish to add, I'd be happy to hear that.
I keep coming back to human-human conversation, human-to-human conversation. Like, do we have that mapping? Like, do I have that mapping with anybody in the world? Like, even my husband, my best friend, my sister. I don't know if I have that, like, perfect mapping.
No, I mean, that's why you have, like, endless novels and movies, right? I mean, because that mapping is just, yeah, fundamentally not understood or not complete, I guess.
That's right. And it goes back to the defining the right abstraction of the language that we want to define, for example, in this neologism work. If your goal is to build a building together with a bunch of international people, there's totally a way to define language and signals and communication styles so that you can successfully build that building together, even though you can't talk about meaning of life in depth with these people. right? And there's also a way, it seems, personal experience, there's also a way to communicate complex concepts across culture where the direct one-to-one mapping does not exist, right? For example, of my husband and myself. So I think the practical eye on the question and the problem, whether that is about deception, hallucination, or just working together, empowering human, whatever it might be, really having a laser focus on the goal. With that goal, I think a lot can be done.
Similarly with machines, if we communicate to machine like, hey, this is that our common goal, and like if we see that machine behave in the way that it's actually moving towards that goal, then it sort of gives us confidence that it's like sort of aligned, or at least like we have some like understanding of what's happening, like awareness of the situation. Is this what it is?
We can't stop there, yes, and we can't stop there, though. We have to do our due diligence to test whether what it does is what it said it would do. It's a similar question about cooperations between two countries. You have to do sanity check. You have to do your homework to say, okay, is this getting done? Are they doing what we said it to do? So all the safety checks are all still very important.
Given some of the intertwining of language and cognition and how these things work, are there any concerns, given underlying biases in the data these are trained on and the people who tend to work in these spaces, of either propagating or just reflecting those concerns in how we communicate and what we develop as we create these neologisms and new language?
And I think there are lots of problems pointed out in public space. I just actually came back from an internal gathering of people who thinks a lot about this problem and putting ourselves in a position not as an authority to decide what is the right answer to a tricky question or not, but as putting a technical hat and think about what can we do, which expert should we bring to the table to have a discussion about what does this even mean, like how the cultural implications, stereotyping, and all these things should shape LLM, then in turn it potentially will shape the society. So absolutely a concern. Many people are working on it internally and externally. Something that I think about a lot, having young kids myself, and the life they're gonna live would look different. Their circle of communication, like people they access or information that they will access, will be so different than the ones that I had. I lived in a bubble. I lived in a happy little bubble. In their lives will be different. And I continue to think about how my job, and this governs all my decisions on a little personal note, perhaps, is that how what I do at work will shape the society that my kids will live. And I have this imaginary conversation with my son when he's 5 years old, but at one point he will turn into teenager, maybe 16, and he'll come to me and say, Oma, did you work on this AI thing? And I'll be like, yes. And I don't want him to go and say, I am so embarrassed, I'm not going to tell my friends, right? That's probably a nightmare for a lot of parents, that I want him to be proud that I worked on and I changed the course of development of AI into something more positive. And I want him to say, oh, that's awesome, this and that work that steered the direction for the society. That's something what I think about a lot and really governs what I do every day.
For some reason, I think like he will be proud regardless, because he knows that, like you're doing your best. And the problem is so like complicated that, like with the effort that the entire community puts, like we still don't know what will be the outcome, right? But like,
well, we have to make a dent, and I think this community who came to this room and on the BuzzRobot is like the community who cares about these problems, like either safety or technology and its development, its interaction with the society, and everyone has to work together or work separately or find a solution for everybody once and for all, for us and our next generation. We want to make a dent.
Can you say more about how you would go about extending some of your recent chess work to domains like biology?
We are thinking about math right now because it's a little more constrained, but biology is also a good question. Like if you take just AlphaFold example. Okay, so there's different domains. There are domains where once you have the solution, you know that you have it. You have something superhuman, like chess, like math, biology and protein folding case sometimes. And then there are domains that you don't even know whether you have that solution or not. In other words, the difference between these two domains is whether you have a validator or you don't have the validator. For the biology problem, for problems in biology that you have a validator, then I think answer is pretty straightforward, and I'm sure many people are doing this to hill climb, trying to teach humans and make the solution that works for a lot of people. It's really tricky, much more tricky when you don't have that validator. But even then, some approaches that we are thinking about are whether we could much simplify the problem such that we can have a validator and choose the problem that one makes a dent, it's worth perhaps saving lives and changing other people's lives. And two, whether experimentation is cheap. So that if you have many solutions and you don't, only validator is to experiment and in wet lab and whatnot, then you could roll this out quickly and have the validation quickly. So it's also about choosing the problem.
Thank you for this beautiful topic. The question I have is, when we teach these models, why are they bound to work? Is the first question. If they are bound to work by some natural forces, how do they work? Does that mean that we are teaching the electrons or the atoms with some lookup mechanism, provide them with a dictionary? If that is true, does that mean that these electrons or atoms have or perform any kind of sentience? Are they intelligent? So that's kind of the question.
I guess the whole point of interpretability is trying to figure out how it works and answer those questions. Sentient, I am not qualified to have that conversation. I don't really know what it means to be sentient. And I think that's pretty philosophical more rather than technical. It's like
I'm thinking about this at some extremes here, but I think a lot of, I guess, concepts that we have are hard to put labels on. We don't even have words for them. And I'm thinking, for example, sometimes there will be something that needs to be fixed or adjusted, or a lid that needs to be taken off in a way. Sometimes my wife will say, I can't figure out how to do this. She'll hand it to me and I'll kind of look at it and I say, oh, you do this, boom. And it's not like there's a word for it. There's some kind of concepts that are involved. But it's, I'm kind of highlighting this because they're, very, I guess, non-crisp. I wouldn't even be able to tell you what it was I knew that allowed me to do that, where she wasn't able to, or, vice versa. Neologisms just kind of strike me as being very crisp. I mean, I don't know. Maybe it reminds me of the work like Goodman's Grew and Bleen. Neologisms, I guess. I also kind of, some of this is thinking in terms of human crisp concepts, but maybe there's no such thing as a concept in an LLM. So, I want to kind of push on it in these dimensions, if that makes sense.
What if we have concepts that we don't even know how to verbalize, but we do it? There are other ways to perhaps communicate this, and crisp definition for a word seems like too simplified version of this very complex problem. Let's go back to how humans invent words. When humans invent words, what we do is we sprung out a bunch of words, and only the words that get reused survive. And then after a few years, it enters the Merriam dictionary. It's like a big deal. I think Skibidi entered it this year, that they became part of a dictionary. What does that mean in this evolution of language evolution? By the way, Korean is apparently one of the fastest evolving language in the whole world. We're a pretty homogeneous society. We keep inventing words, and a lot of words get dropped every year. A lot of words enter dictionary. It's a really, really interesting dynamics. And I think same dynamics of survival of, words applies in neologism. Like if it's something that you can just do it and no one else, your uncle doesn't call you next day and say like, I don't know how to do this, Lonnie, and like, some of your friend calls you that I don't know how you do that either, then like you have now need to create a word for that thing that you just helped your wife with. But if it's just one thing, you're just going to do it and move on with your life. And I think same thing applies to the words too. Even if word is something complicated, if there's a need for it, then we will probably cut out some fat of that meaning so that it's succinct to communicate to somebody so that we can achieve the goal. And what is the goal? To help the other person. We're communicating something succinct to control the model.
Okay, so there's a communication layer, which is where you're focused, I guess. I guess I'm not quite convinced that there's even a set of concepts inside the LLM, that maybe everything is continuous, and communication is a matter of it kind of approximating our crisp language in some kind of continuous space. I mean, I encounter this in human language too. An example lately is the word agent. Or agency. People use that as a crisp term. I kind of tend to say, no, there's different degrees of agency, and might question whether there even is a language or a set of concepts on the LLM side that, that
Do you
need
think
to
there are
be
set of
right?
concepts that are not continuous in human minds? I think concepts are very complicated in human minds too, but somehow we make it work, right? We make it communicate. We cut it out, and agent is a great word, great example. Like no one knows what it means. There's some definitions, like everyone uses it for everything. So when we wrote the agentic interpretability paper, we just kind of was tongue in cheek. We're like, let's throw that word in. And Neil Danda was one of the co-authors of this paper, and he was like, yeah, why not? And so we kind of almost played in the word, and it's the same thing. I think the concept is not crisp to anybody. It's just a means to an end.
My question was maybe a little bit related to this, which is, teaching concepts where it's sort of very abstract, like concept of humor. If you ask a model to be funny, they can sort of tell you a joke, but what's your intuition about whether they have some actual internal representation of the concept of humor, and what does that look like? And do you think they're capable of creating novel contributions to that concept at some point?
This reminds you of coming back to, again, human analogy to me. So what's funny is very different culture to culture, right? In Korea, there's no such thing as sarcasm. Well, now maybe it is, but not back when I was a kid in Korea. So when I moved to US, sarcasm was the weirdest thing to me. Like, why is this funny? But now I adopted to what's funny, the definition of funny in US, and now I think sarcasm is hilarious, and I use it myself. I think when LLMs, it's a conjecture, but when LLMs are taught what is funny and trying to figure out what is funny to users, it might be doing something similar, that it has some shape or a function of what it might look like, but it doesn't exactly know what it is. But eventually it will sort of adopt itself to, given the user feedback, what is funny. And can it contribute creatively? Absolutely. Have you tried to make a rhyme, make the LLM rhyme about some ridiculous topic? I don't know, like cupcake or something. It's hilarious. Sometimes it's really, really creative. So I think it gives me hope when it comes to topics like creativity. I think LLM, in a positive spin of such technology, LLM can be such a powerful tool for people to create new things and being that inspiration.
AlexNet happened like in 2012, like 13 years later. How do we understand machines better? Like, what has changed in our understanding of machines? Or you feel like we're actually, despite all the things that we're trying, there is no real order of magnitude progress there?
I think everything changed, but despite we did make a progress, and that progress was that we learned about ourselves, that the community really grappled with this failure modes of many explanations, that we can have a confirmation bias, that humans are so good at connecting dots. A lot of random explanation when you place in front of humans, we make a story about it, and we make up story why it makes sense. And in that sense, we did make a progress towards getting somewhere by empowering humans. Did we make a progress in understanding machine in general? I think we made a lot of conceptual progress, thinking about machines and humans, psychology, experiments about just the general nature of these machines. And some methods has been helpful. Insights from either mechanistic interpretability and traditional interpretability field has been really insightful. Lots of more interest, lots of even more work coming out of AI safety community. So in a way, I think we made progress in two ways. We learned more about ourselves, but two, the community got bigger, which means the more heads, the better, right? There are lots of people more smarter than me that we can put our heads together towards solving this problem.